once we are able to use our primary trig ratios in order to solve for missing sides and angles, of course, the next step then is to figure out some applications of this. So we're going to start looking at some word problems. The biggest thing with word problems, of course, is drawing the actual problem, seeing what they are looking for, and sometimes it's the terminology. So let's begin with a little bit of terminology. Two things that we talk about quite often when it comes to trigonometry and trig problems is angles of elevation and angles of depression. So the big thing to realize is that both of them always come from a horizontal line. And a horizontal line, of course, is this line along the bottom. So they always have that horizontal line. And then if it's an angle of elevation, it goes up from there. And if it's an angle of depression, then it goes down from there. And that kind of makes sense, right? We think of depression as down, elevation as up, but it always comes from a horizontal line. So that's a big thing to remember. Okay, so here's our first example. You're flying a kite. You let out 150 meters of string. The kite is at an angle of elevation of 20 degrees from you. Calculate the height of the kite. All right, so we're going to say like this is you. And somewhere up here is the kite. Now, I know, hard to believe, but we always assume that it makes a 90 degrees with the ground, like this. So we know our angle of elevation. So remember, angle of elevation always comes from a horizontal line. So here's my horizontal line. So my angle of elevation is up from there, and it's 20 degrees. And we know we've let out 150 meters of string. And what we're looking for is the height of the kite. So that would be the height if you went directly underneath the kite to the ground. How high is the kite? So here is our right triangle. Now it's just a matter of labeling our sides. So this is my opposite. This is my adjacent. And this is my hypotenuse. And setting up my trig ratio. So I'm looking for my opposite. I have my hypotenuse. Using SOHCAHTOA, which one is opposite and hypotenuse? Well, of course, that's sine. Sine is opposite and hypotenuse. So the sine of 20 degrees is equal to my opposite side over my hypotenuse. From here, we're going to cross multiply. 1 times x is x. 150 sine 20 degrees. And x equals. All right, now I'm getting out my calculator. Once again, making sure my calculator is in degree mode. And I'm going to go 150 sine 20, hit equals, and I get 51.3 meters high. Okay, so now we use our therefore statement. Therefore, the height of the kite is 51.3 meters. Okay. That one wasn't too bad. Let's continue on. Example 2. So we have a sailboat. It's 2 kilometers west of a lighthouse. Rescue plane is 7 kilometers south of the lighthouse. What direction should the plane fly in order to meet the sailboat? So let's begin. The sailboat is 2 kilometers west of the lighthouse. So let's say here's my lighthouse. I'm going to go 2 kilometers west of that. We have a sailboat. So that's 2 kilometers. And a rescue plane is 7 kilometers south. So this is south. And that's 7 kilometers. And that's my plane. All right, what direction should the plane fly to meet the sailboat? So the plane wants to meet the sailboat there. This has created a 90-degree angle. So what direction? So we'll talk about that in a minute, but basically I need to find this angle right here. So important to find that angle. Okay, let's start labeling sides. So if this is the angle I'm looking for, this is my opposite side, this is my adjacent side, and this is my hypotenuse. And so with SOHCAHTOA, which primary trig ratio uses opposite and adjacent, since those are the two sides that we have? Opposite and adjacent is going to be tan. Tan theta is equal to my opposite side, which is 2, over my adjacent side, which is 7. I want theta, so I'm going to have to get rid of the tan by taking the tan inverse of each side. And theta is equal to tan inverse of 2/7. Theta is all right, second function, tan bracket 2 divided by 7 bracket equals, and I get 16, if I round that properly, 16 degrees, which means that this angle in here is 16 degrees. So just as we're talking about direction, for those of you who maybe aren't so good with direction, so north is up top, south, east, and west, and we want him to go in this direction, so in here somewhere. Whoops, just a sec. Let me just clean that up a bit. Oh, my alignment's off. North, south, east, west. And this is where my 16 degrees is in here. So see how it's on the north, it's in between north and west. So we can say 16 degrees northwest is the direction the plane will follow. Good. Okay, let's try, I think, one more and see how we do. All right, Eddie is standing at the top of a 12-meter building. The angle of depression from Eddie to the bottom of the second building is 32 degrees. The angle of elevation to the top of the second building is 38 degrees. Determine the distance between the two buildings. Okay, so we have two buildings. So let me just draw these two buildings here. So it's like here's building A, here's building B. We have Eddie, who is standing on top of building A, which is 12 meters high. Now the angle of depression from Eddie to the bottom of the second building is 32 degrees. So remember I said angles of elevation, angles of depression always come from horizontal lines. So here's my horizontal line, here's my angle of depression, and that angle in there is 32 degrees. The angle of elevation to the top of the second building, whoops, so I drew this one wrong because it's Eddie and it's an angle of elevation. So that means building B must look something like that. So the angle to the top of the building is 38 degrees because he looked up. That means that building must be higher if he's looking up. Okay, determine the distance between the two buildings. So what I'm looking for then is my distance between A and B, which is right there. Okay, so let me pull that triangle out. So this is what we have. We have our 90 degrees right here. This is 12. This is X. Now it looks like we don't have an angle in that top corner, but since I have that angle on the outside of it, so since this is 32, I can take 90 degrees and subtract 32, which would give me 58. That means my angle right here must be 58 degrees. Okay, so let's label our sides. This is opposite. This is adjacent. This is hypotenuse. Opposite and adjacent is going to be tan. Tan 58 equals my opposite side, which I'm looking for, divided by my adjacent side, which is 12. I'm going to cross multiply that, and I get x equals 12 tan 58. X equals, I'm going to go to my calculator, 12 tan 58 equals 19.2. So the distance between the two buildings, that was A. Distance between buildings is 19.2 meters. All right, let's go for B. What is the height of the second building? Oh, jeepers. Okay, well, I know part of it. I know that my height between here and here is 12. I just need to figure out this part right here, or in other words, this part right here. Okay, so looking at this, I'm going to redraw it. This is what I have. I have 38, and I'm looking for this part Y. And even though it doesn't have it right directly on that triangle, if I look below, that distance between the two buildings was X, and we actually figured that out. We figured it out that it's 19.2. So I do have that side length. And now if I label my sides, Y is opposite, 19.2 is adjacent, and then I have my hypotenuse. Again, looking at my trig ratios, which one has opposite and adjacent? It's going to be tan. So I'm going to say tan of 38 degrees is equal to my opposite side, which is Y, over my adjacent side, which is 19.2. I'm going to cross multiply that, and I get Y equals 19.2 tan 38, which is 19.2 tan 38, 15 meters. Okay, so our Y value is 15 meters. Our Y value is 15 meters. Now that is not the total height of the second building. Total height of the second building, of course, is going to be the total height of building B is that 12 plus 15, which is 27 meters tall. Okay, definitely a bigger problem. Notice that we had to find some sides and then use them in other places, and we had angles of elevation, angles of depression. So this is certainly a much more difficult question to do than the other ones, only because we had all these kind of triangles going on. Okay, so the big thing with word problems is practice. Practice, practice, practice. Draw a diagram so you can see what you're trying to find, and then from there, set up your primary trig ratios. As always, if you're looking for help, just reach out.